Okay, so I made this wormy guy for a demo, but I thought it was kind of fun. How do we play this? What I'm showing is a tension solver. So the wrinkles or the colors are procedural, and some of the wrinkles are procedural. And I thought I would show how to do that inside. I actually created the guy inside Houdini. Not that anybody needs to do that, but it's kind of fun. There's some little tricks along here that I think are helpful. Um, Rather than walk you through all this, I was going to try to record a new one. So let's create a new node and start at the top. So I'm cheating a little. I have another scene on the side here, but oh yeah, I forgot a Tommy so we can see what the scale is and which way we're facing. So that was the way I made the other one. Um, and then we'll scale these down. Let's see, this one, 2, 13, 24, looks right. That's what we did last time. And then we need, let's make, there's a more clever way to make these groups, but what I'll do is I want the front and the back to be separate groups. That, and then I usually do $OS, that'll take the name of the node. So this one will be called group 1, this one will be called group 2. And this one will say not group 1. We get the back half. Okay. Now, what did I do over there? Transform. Oh yeah, I threw a little squish in. So I squished it down a little bit. And then we extrude. We'll extrude the front and the back. Um, this. So this will be group 1. Oh, this will be group 2. Okay. And then what do we want to do? So we're gonna stretch it out. Not that way. It's a bit of a trick figuring this out this last time. I want extrusion, transform, extrude front. And it's this one here. So I sent it out 1. And this one will do -1, I assume. No, 1 was correct. Okay, we need some divisions. I already know that this is a number, but I was trying to keep them kind of square. Okay, and then through a smooth in. That was to soften this corners up here mostly. Turn that up. Okay. Next we need some UVs on this guy. So we'll add UV flatten. And then what did we do? There's a couple things here. So we've got yeah, so we don't want the ends. So we could do like I don't think I can do both like this. Maybe I could use ampersand or something. Yeah, no, it's not gonna work. I'll just do it um, the lazy way. Middle mouse. Okay. Select all this. Get the other side. So it's like I select, press Shift A, middle mouse. The tooltips are on the bottom there as well when you're doing it. Yeah, so now if I press spacebar 5, sorry, tummy. Oh, we got nothing yet. Okay, so we need more. We need seams. So for seams, let's pick the same loop. And we need the bottom. So I think that should be it. Yeah. Make this a touch bigger. And then what do we do on the other side? That maybe one less, or maybe one more on this side, actually. Like that. Okay, now when we look in here, we should have, there we go. What do we need? Maybe flatten. So that, okay, I think that was it maybe? Yeah, so for some reason, enable manual layout rotates it. And then we need a UV project is what I wanted actually. So we will, that's for the ends. So we want group 1, group 2 only. I think that's all we do with those for this round. And then we do a couple more things to fix those. So we have UV smooth. Apply that to the same groups. Maybe that turned up pretty high. Yeah, I cheated a little and I moved that seam up one more edge loop so that when I flatten it, these edges are a bit straighter. Okay, so we got the UV project, UV smooth on that one. And then what do we need? We need a UV transform. At the moment, one of these is going to be flipped in the wrong direction. It's inverted, right? Because the projection is just coming from both ends and they're overlapping. How can I show that? So if I turn on UVs, I can see that this side is readable correctly, and this side, everything's backwards. So what I want to do is pick the correct group if I can, and then I will flip the scale. Where's one? So that's it. That one's fixed. This one's still fixed. They're still correct. We can see that the textile density is wrong. These squares are bigger than these squares, so we want to fix that. At the same time, I think we can do, yeah, we do a UV layout. Put that down. Okay, so that just lays everything out nicely. And let me just check my settings so I don't have to faff about. So we've got, yeah, scale, axis alignment, none we did, and we need some island padding. The other thing I like to do, where is it? Target rectangle. Yeah, so instead of the whole rectangle, we can just do 0.99, 0.99. And that gives us a little bit of border around the sides, but without saying apply padding between. Because really on the sides, you only need half the amount. Because if I add this half plus this half, I'm going to get to the same amount of padding. I don't know if that makes sense, but it's an old trick I used to do when I worked in games, which this stuff really mattered. You gotta keep every pixel you can. Something like that. That's fine. Okay. Now what? I think now, at least in my other file, I have a clean, yeah, because I don't want to keep these. So I usually use a clean. You can use delete attributes or whatever, but I think I'll keep the groups for now. But I could just select those there. Or I could do the opposite. You could do star and then do ignore UV. So that'll clean everything except keep the UVs. Which can be helpful if you have a million attributes and you only want to keep 3. Keep Tommy around. Keep telling me for scale and for direction. Okay, so that was the end of just creating our 2B guy. Pretty basic. Fast forward that part. And then the next part I think that's fun is, let's see. So I'm going to press Control 1 to create a bookmark here. If we go back to our other scene, I'll press Control 2. So the fun part, not the fun part, but a useful thing is to be able to, what we want to do next is, eventually create a skeleton joint chain for this. And so how do you get a tube, how do you get a point that goes right down the middle? Well, this is just a straight tube, so maybe that's pretty easy. But you could just grab the endpoints and then create a line between and resample and add as many as you want. However, I've often had to come across a tube that is wrapped around a character like a necklace or something, and it's harder. So this is a really nice way to create a line of points that goes right down the center of the tube perfectly. So while this isn't the best way to do it for this case, it's really helpful. So I'll just demo it quick. So what we'll do is we need to define the ends. So this is the one non-procedural part here. So I'm sure you could, write something to do this. But what I want is it's just one end actually. Can't remember which one. I'll try this one. Enter. Okay, so actually last time I did, let's see if I did the same one. 24, yeah. Okay, now we need activity. What are we doing with that? Nothing, just get all the connected points. Okay, and then we'll do a for each, and it is, 1 second. Okay, it's for each piece or point. What is that, this? Yes, for each primitive. Okay, so go down here somewhere. Okay, now we need a group expand. What we want to do with this one is we want base group is end, blood filled to connected geometry, create a step attribute. What are we on? Missing template geometry. Okay. I'm gonna keep plowing forward and see if this for each end. Oh, okay. Let's grab a class. Primitives, merge. Oh, it's not connected. Maybe you've been seeing that the whole time, but I missed that. Okay, now we want to fuse by matching attribute step, and we will turn that one off. And average value. Is that right? Remove unused points. Okay, there we go. Now we want, I threw a sort in there, and sort by step. Sort point by attribute. Point sort by attribute is here somewhere. There it is. Good grief. Step. Okay. So that should, I assume that's fixing our numbering so it's in order. Starting with the step. Okay. Now we'll add our line. Why doesn't that look right? There we go. It's possible that my other scene was wrong. But okay, we got that. We got a resample. That'll be everything. A resample should be, get some parameters in there. So I think you can do whatever you need here. In my other scene I have 0025, which seems like maybe I just didn't look at it. Copied it from an old necklace or something. Because I resample it later to 0.1. Yeah, so let's just keep it like that. It probably will work. Looks right. Now same thing, we've got some extra values. I'll probably just kill like step and group. And in fact, I killed all of them in my other scene. Oh yeah, you should turn these off first, because otherwise it might blow up. Sometimes it blows up if you have removed degenerates and all this stuff on. Okay, so now I've got a clean line. Now what I can do is add a skeleton. And that's it. This is a skeleton now. So if I look at the rig tree, I have a hierarchy of essentially joints, because in Houdini all joints are as a bunch of points. So I do need a couple more things, like they'll make it look more like a skeleton in a second. So you orient them. I think, what do we need? Up vector. That's all correct. We don't need to change anything. We could, yeah, we won't, let's visualize them. Viz rig. So throw a viz rig in. Now we have these Nomen hats. So we can see the X is the twist, and everything else is as expected. Y is up. Right? Yeah, show parent to child. Parent to child. This also points at which direction the hierarchy is going. That can be helpful. Okay. Now, can't remember why I need this, but let's add it anyway. Well, I'm sure we'll touch it later. Sqworm joints. Hey, one thing that we're missing is a nice root. So basically when I animate this guy, I need a root that stays at 0, 0, so that something like Unreal will know where it's gone. Otherwise, the location's just not going to be right. So what I'll do is add a point here, just a single point. 1 point at 0, 0. Okay. Now let's turn that into a skeleton. One thing to be aware of is these have a stash. So as far as I know, yeah, I haven't dug into this. Maybe it's part of the Python. But if you stash this, and I guess it probably stashes when you first plug in, and then you change stuff upstream, it won't update. So it is important to remember that these are kind of live nodes that you need to come back to if you change anything up here. So if I want to change the length of the Sqworm, everything else will be procedural, but then I'll just need to hit that stash button again. It's not great, but it's this is how it works right now. So let's orient that join as well, just to make sure. What do we have? Same thing. Yeah, we could throw the viz rig over there. Okay. There's our root. What else do I have? I have an attribute string edit. So there's 10 ways you can do this, but what I'm going to do is just rename that. I don't know if I need to do this, but I'm going to type name, because the 0.0, like the name that I'm getting from the skeleton crate, is name 0.0. or somewhere. Yeah, the skeleton crate. What I actually want that to be called is name. So I'm going to call it, I'm going to type 0 to root. And that'll be, we'll just make sure that it's very recognizable to the engine, Unreal. Okay, let's merge those. Now they're just on top of each other, but it's not actually the root yet. It's like two different skeletons. So we can do apparent joints. Okay, and just checking my work here. So on the other scene, yeah, the ordering is 0 to 22. That's right. Okay, so what we want is apparent joint. Parent is a root. Now if we look in here, do we get it? No. Yes. Yes, we did. So root to parent. So see why that's more helpful as we go. The next thing I want to do is, well, I can show you right now probably, is add some animation. So I'll set that aside as well. So I've got, finish that step. So here's the skeleton creation, basically. Geometry creation. And then we'll start animation. So what we do is, yeah, so I've just transformed it up. 0.42 is exactly what I did last time. Actually, I don't want the root. I only want the Sqworm joints. That's one place I use that. You could probably also use a pattern like against the point name. No? Whatever. Probably made a mistake. Sqworm joints, let's just go with that for now because we have it. And then what else did I do? Previously I squished it a little bit because it looked better. Okay, so for the sine wave, you know what, I'm just going to copy paste that over. It looks like this. So I borrowed this from a tutorial somewhere, I think, and modified it a bunch because the results I wanted were different. So what this is doing is, if I play now, where's Tommy? Oh yeah, yeah. That's why I keep him. I was looking the wrong way. I was looking at the back and wondering why it looked like it was going backwards. So there we go. So now it's swimming up and down a sine wave. So you know, using this, you can change the scale of it, the frequency. Slider doesn't quite work. There we go. Change the frequency. Speed, obviously the speed, it's in the negative because I wanted it to look like it's going the other way. There we go. So with the speed, I've reversed the direction basically. Okay, now Labs has a cool node called make loop. Oopsie. If you don't have Labs, you should grab it. You can get it from your launcher. And then it'll be, you know, you'll see it show up here, but also they add a whole bunch of useful stuff. Yeah, so when you're looking for nodes, often one of those will pop up and you can give it a try. They're also not black box, so you can just pop in here and grab, you know, the bit you like and make it your own. Pull it out into your network, or you could probably make them unlockable. Anyway, enough about that. Let's see. Now what I've done here is I've animated this in kind of a, if you're a Maya user, you'll know that this was kind of a bad way. You don't just morph stuff around like this. However, in Houdini, you're allowed. It doesn't care. But we do have this problem right now is these are going the wrong way. So we're going to need to reorient again. So I think I can just use one of the same ones, right? And that's going to fix the orientation. So another thing, we know that when we throw this into Unreal or onto the character, it will squish everything. There'll be transformation on the joints. At this point in time, that works inside Unreal. So I don't think it used to work, but whatever, it's fine now. Okay, so what we want to do is let's throw this onto our character finally. So we need a joint biharmonic capture. So we'll get some skinning going. So we'll take this, you know what, I think I'll add a null here. We're going to call this rest and bring that into our biharmonic. Now we need capture pose. So what's our capture pose? It's got to be this, right? And then we need our animation. Do we? We don't really need the animated pose here, but we'll pass it through to the next step. Okay. And for this, I don't even think did I change anything? Well, we don't want the root. Let's just say not root. Last time I did. What's going on here? Capture biharmonic, capture proximity. Oh, I used a different node last time, that's why. So either looks like it would work, but let's use this instead. Okay. Turn off all this noise. There we go. So we can see our weighting. Very colorful. Max influences doesn't really matter. You can see it. If I do this, it's going to get harder edges as it animates. I have 6, so it's pretty fuzzy right now. It should be pretty blobby. And then let's deform it. So we got a joint deform. I think it's the modern version of bone. Bone deform is still around here, but I think joint deform is the more current one. We can just pass the animation down. To connect all 3 at once, I pressed cut Y. To get all 3 of them, I'm holding J while I'm doing this and dragging down, and it connects all 3. Okay. So there we go. Got an animated little squirm. I feel like my joint orientation is not quite the same. Let me see what's happening there. See, one thing I was trying to fix is this flat face here. So if I go to the, let's jump to my old scene. So nothing changed in there. If I look at the rig. Okay, let's pop back to the other one, which was on bookmark 1. Yes. Rig. Interesting. So it's slightly different. So there's something I missed here. I might just pause and debug for a second. Okay, I figured it out. A couple things. One, I forgot to mention what this make loop is doing. It is making an actual loop. So it's, if we look at before and after, press E to template. Let's hide this for a second. So you can see the position's actually different here. So, boy, I can't remember how to explain this right now. But it's actually looking at some amount of frames and making a loop out of it. So if I just look at this one and then I skip to the end, you can see it's just stepping one frame and it loops. If I look at this one, and I looked at that frame number and picked 45 as like a decent place to loop. You can see this one almost loops, but it doesn't. There's a tiny pop in there. So I just threw this in there and it makes it a perfect loop. Okay, and then the thing that I realized was the error in my scene is yeah, what's happening? This is Geo1. So if I look in the original, well, maybe it's not the problem. 1100. Ah, yeah, that was maybe it. It was well, at least certainly down there I have not root. Does that make a difference? Let's check the visrig. Probably not. Identical. Also, what I'm doing here is I've got this nifty little thing. Um, this view down here can be navigated independently of this view, which is a nice way to kind of open two scenes at once. So right now I have this, not two scenes, but two different areas. You could go anywhere, right? This could be, somewhere else. But the way it works is you use this link pane. So we've got two, and over here we've got two. And up here we've got one and one. So these are linked. These are linked. And that lets me open an extra window basically. Okay, let's just move on and I'll figure that out at some point. Okay, so we're just looking at our current guy. We got our joint deform, and okay, so let's call it anim. Sorry, that's an Apex node. I was trying to check the video time and I zoned out a second. Anim. Okay, so what we want to do now is, basically we're done. I would like to solve that facing problem if it's not already. Let's go into Sqworm here and turn on anim, turn off points. And then if we go back here, are they the same? Looks like they're the same. So what I'm doing is I'm pressing Y and it's ghosting the other things that are visible. I guess I didn't have a problem in the first place. I thought I did though, or maybe it was a bug. Could have been a bug. Okay, so let's ghost the other one again. One thing I did in the other scene though is I want more resolution, so I'm going to throw down a subdivide here, a little bit higher, and then I don't know if you noticed, but the normals were looking pretty bad there. Let's redo the normals. I don't want any hard edges, so I'll just turn that up. Okay. Now, that's basically it. But I do want to, excuse me, measure the tension, get everything lined up perfectly. So exporting this to Unreal is a whole other trick. This video is pretty long. Oh, let's add the wrinkle deformer. Wrinkle deformer. That is something definitely I wanted to add. So for that we need geometry to deform, rest geometry, and collision geometry. So I don't think we'll use collision geometry. So what we need is, what's coming in is our joint deform. Or might as well put in this anim one. Okay, so this is kind of fun. So the nice thing about this is we can use it for machine learning easily because it's quasi-static. It's computed quasi-static. Basically, each frame before doesn't matter. Like if you do a simulation, all the frames before really matter. Like you need all those. But for machine learning, you can't have that. It needs to be quasi-static where each frame is independent. So if you throw a punch and your shirt sleeve slides down, and then you reverse it, you're going the other way, you don't want the shirt sleeve to kind of slide back in the wrong direction. It's a little bit hard to explain, but it's basically like stop motion is what we need going in. For some reason, this doesn't seem to work how I want it. I'm going to recalculate the normals again. Okay. And then we've got a some export stuff. Basically, I'll just drag this over though. This is what I've got is the, oh yeah, I do want that object merge rest, and what's this? Okay, so what I'm going to do is measure the tension. Oh, my wrinkle deformer is not tuned properly. I'll try to tune it a little bit. So we could either drag this up so we can see. So this one has slightly better, results that I liked better. So let's fix this up. So we've got higher constraint iterations, surface struts, 0.98, so we're letting it shrink a little bit. Compression stiffness. We will turn on collision so it collides with its old position, I believe is what it's doing. We just fix the scale of it. So there's like a slight offset. Yeah, so that allows it to collapse a little bit. 3 is what I had, and turn that down, turn that up. Okay. That's what I had in the previous one. Doesn't look quite right yet. I wonder if I missed anything. Doesn't look like it. Yeah, it's wrinkly. Okay, so now if I animate or if I play, you can see those wrinkles moving along. Measure the tension, so it's measuring these are kind of swapped. The rest going in, so this is where it used to be. And then it's going, where is it now? And measuring the edge length. And then outputting a value. And then I'm writing that value to a color. So that value that's coming out is called stretch. So you can see there's negative 0.08, or negative 7 is the highest, and negative 0.9 positive is the highest. Yeah, so now we can see that animate. So I've changed the bias slightly to get it results that I like a little bit more. So you can change the bias. And then I write that out to an alembic and animate on top of it in Unreal. But that's a bit of another video, Unreal side. And this is doing the same thing, it's just not writing out a CD. So on here I changed the center location. But yeah, you can write that out to an alembic and then work with it in Unreal, like get that vertex color inside your shader. That's it. But yeah, and if we're not, exporting an alembic, right? Like we probably want a skin cluster mesh. What we can do is, export this, and we've got our skin cluster. So we need, maybe I will show a little bit of that. Got anim, rest, measure tension, visualize. So this is just the skin cluster version of what that would look like. But the export for Unreal, so if we want to export this like a character we've created, a beautiful character, let's move these aside. as they were. And we're going to need some things here. So this is attrib create. So you can create this inside this node, or you can write some vex. If I'm just doing one little thing, I might just write some, or I might just use this node. It's easy. Okay, so that creates a primitive value, giving it a name, and we just need that to keep everything from complaining. Here is some old vex I have. So to create an attribute Wrinkle, I usually use this for Maya, or I used to use this for Maya, but it's obviously useful to create a path attribute in many different things. So this is going to be the folder name, and this will be the name of the geo inside. And I'm missing a couple things. I didn't create those attributes, so I called it, yeah, group suffix group and geo. That just gives a little name, so the engine likes it better. I could probably at some point remove I don't know where my group went, or where I deleted my group previously, but I don't need that group in here, so that's gonna bug me. Let's just throw another clean down. That's a good habit anyway, throw a clean, so now I've just deleted everything. We do want to keep some things, obviously. Normals, these, bone capture. I think we might as well keep those too. Okay, so we're not going to delete any attributes. I will just delete the groups. There we go. Okay, and then I do like to throw a null down just to see these things. What's passing through this joint capture is what's passing through this node is the rest. Like if I click on this, I'm just going to see the rest. So I want to be able to see what these are. So this is the bind pose. You might know it as, or rest skeleton. And then this is the anim. Anim skull. Rest skull. Okay, let's throw a drop fbx output, character output. And with this one, I can pack animation and character all in one. And I'll just drag the output of this to my Unreal project. And if I just double check the settings so I don't have to figure it out on the fly live. So yeah, we want we'll render the current frame range. Compatibility. This doesn't work. We'll have to change it a little bit. So you convert, turn that off. Move scaling is off or on. And we want Y up left-handed, I think right-handed is the default. So for whatever reason, those things don't work properly anymore. We just want it like that. That preset doesn't work. I created a clip name. I don't know if you need a clip name. Might just suppress an error. Okay, that's it. Now if I hit export on that, we should get our rest mesh, which is weighted to this, which, yeah, I see they both have well, they have all the attributes they need. So we have an animation with the root offset. So if I drop it in, this root will be at 0, 0, and then the animation will be above that. And then, yeah, we just hit export. Save the disk. All right, why not just keep going? Let's go open show file in browser. So that takes me to my hip location, which is because I uploaded my folder, my file, just to the hip location. So we got out.fbx. So if we drag that into Unreal, I see I've turned off the interchain format, so I might keep that on for this. Let's see if it's in my history. So interchange feature flag, I had it off in the config file because the transformation import, if you want to transform stuff on import, I don't think that's working. But this one, yeah, I don't think it's working in here, so you need the old one. Anyway, just leave all this. I think I'll turn on. The thing I keep forgetting to turn off is the physics, create physics asset. I don't need import. So you have animation sequence, skeletal mesh, and skeleton. So if I click on this, it's all just connected and ready to go. There we have it. Then you make yourself funny material and off to the races. If we did want to throw it in the scene quick, yeah, let's name the stuff properly. So we call it SK Sqworm for this version. Animation is AS worm. Just so you know, it's good to name stuff properly. Sqworm. These are following a naming scheme that is really common. Use animation asset. It's the only one that matches. And then there we go. So if I hit play, the other one won't animate unless I hit play here. All right, Finny.